Hi, Benice. Can you actually hear me? Good morning, Benice. Testing 1, 2. Can you actually hear me, Benice? Good morning. I can see your mic is unmuted, but I can't hear you. Good morning, Benice. Morning, Kutso. Can you actually hear me? Good morning, Kutso. Can you actually hear me?
Yeah, I can hear you.
Okay, it's only Benice. We can't hear. I can't hear. Her mic is probably, volume is probably low, or she didn't select the mic or something, or she's not. Right.
Hear me now.
Sorry?
You hear me now?
Yeah, I can hear you now. Okay, Benice, we need you to set up your mic properly. Otherwise, you just need to leave the meeting and just rejoin, because your mic probably didn't start up with the meeting. I can see it, but the volume is either too low or it's not connecting. Okay, Kutso, what are we busy with?
I'm doing revision now.
Revision, but you haven't completed everything yet.
I kind of did already.
Pardon?
I think, yeah, no, it's chemical equilibrium. I kind of did already. I'm doing revision while doing the work at the same time.
Okay.
But
So have you done the chapter on chemical equilibrium?
chemical. I've done a bit of it.
Okay. Have you done Le Chatelier's principle?
No, I haven't done that.
We're just waiting for Bernice because I don't want to do this chapter unless you've both done it. There's too much explaining to do. It will take me more than a lesson just to explain the Chatelier's principle. And if you can actually do it on your own, then we can focus more on examples to apply it.
All right.
So what are you doing revision on?
Mainly mechanics. I think that's the one that I have to focus on the most.
We'll just wait for her. My mic is not switched on. Okay, so Newton and energy and work and universal gravitation. Okay, your mic's on now at the moment, Bernice. You just need to. I can hear you. It's not loud enough, but I can. You speak again?
Hello.
Okay, there we go. That's better. All right. Okay, let's just take stock. We're supposed to do chemical equilibrium today. But unless you've gone through that chapter on your own, I'm not going to do it because there's so much work that you need to read and learn to actually understand the chapter. I would like to do examples on that chapter after you've done the work. I can't explain through that chapter. It will take too long. It will take more than 2 lessons to explain through the chapter. So have you done that chapter before, Bernice? Not yet.
No, I haven't done it.
Okay. So what we're going to do, we're just going to leave these two, or this for now. We can always do it next week. So the chemical equilibrium, we're not going to do today. I want you both to work through that chapter first. And I want to do examples rather than re-explain everything. It's actually a huge chapter. Right. So we have an option. We can work with stoichiometry and acid and bases, or with pH. This is grade 11 work, that part. The normal stoichiometry with acids and bases. The new section that we have to add to that is calculating pH values. And that we can easily explain without you doing the chapter. So are you game for that or something else?
Yeah, I think it will be good to refresh.
Okay. Remember, my role is to assist you. Because we're only meeting up once a week, it's not possible for me to teach through the whole syllabus. I'm here to help you with the stuff that you've already gone through, and to clarify things and to explain things you don't understand. It's not possible to do one lesson per week and teach through the syllabus. Also, you're writing on too many chapters from this June exam. It makes it even more harder. So what I'm going to do, I'm going to talk about pH values, and we're going to do some calculations. And then we're going to incorporate those pH sums in your stoichiometry because they like intersect with one another, the two sections. Okay. So new section group, acids and bases. Okay. Acids and bases are probably the section that people in general do the worst in. It's a huge part. It includes stoichiometry and titrations. Can you remember what a titration is? Who of you can remember what a titration is?
No.
A titration is where you actually do experiment with this acid and a base. You throw a catalyst in. So I'll quickly make a little drawing for you. So for instance, we've got a conical flask there. And we fill it up with or we add some base to it. Right. Let's say sodium hydroxide. Okay. So basically what we know here, we know the volume. We can determine the volume. We can exactly determine or put a specific volume of sodium hydroxide into that test tube. But let's say the concentration we don't know. Then we take a burette. A burette is a long pipe You've probably seen this with a little tap. And then you add an acid to that. It's called a standard solution. In other words, we're going to add an acid because we titrate the acid on top of a base. So our base is sodium hydroxide and our acid is, say, for instance, hydrochloric acid. You can titrate the acid on top of a base or a base on top of an acid. Why? Because the two neutralize one another. And then you put in a little indicator. The indicator will change color if all the base has been neutralized by that acid. And because that's a pure red, you can actually determine exactly the volume that you put in. So the volume, again, you're going to know. And the concentration you've predetermined of that acid. And then you can exactly determine the concentration of that sodium hydroxide or the base. The minute the color changes, the sodium hydroxide is being used fully, or we call it, it's neutralized. Okay, but now, normally we've worked with this. Mole is concentration times volume, and therefore I can work out the amount of moles of acid, and then I use mole is concentration times volume, and then I can use that equation to determine the concentration. But now I can add another element called pH. I don't have to give you the concentration of the acid. I can just give you the pH value of the acid or the pH value of the base. And then you have to rework from the pH value what the concentration is. Also, I don't have to do a titration. I can just add an acid and a base and then measure the pH afterwards. And then you must be able to tell me which one is in excess and what's the concentration in excess and all of that. So before we can do a revision of all of this grade 11 work, because all of this was grade 11, we first have to show you how to calculate and work with pH. So that's what we're going to do. Right. Okay. Right. So the first thing we need to learn is, what does it mean if something is a strong acid or if we have a strong base? Right. There's a couple of strong acids. I'm just going to get my stuff on this. This is titrations and pH. I'm going to get all my work on this ready, because I didn't know we were going to do this. No. Okay, I can't find this now. Just give me a second, so I'll find exactly what I want you to do. Nope. Right. Okay, I think I'm there. There we go. Okay, a strong acid is an acid that will ionize fully. So in other words, if I take that acid, let's say, so it will fully ionize, fully convert into ions. So if I take this acid, HCl, and I add water, this is called ionization. I can draw double arrows, means that reaction will take place in the forward direction and in the reverse direction. So what will happen here, HCl is an acid, it will donate a proton, because that was what an acid does, it donates protons. So that will give me hydronium. So this is a liquid, this is a solution. It will give me hydronium ions in solution and also chlorine ions in solution. So if it's a strong acid, it doesn't matter what concentration I have here. Say for instance, I've got 0.2 moles per cubic deciliter. Then the concentration of the hydronium ions will also be 0.2, and the concentration of the chlorine ions will also be 0.2. Square brackets is just short for concentration. That's what it means to fully ionize, and all strong acids will fully ionize, will convert fully into ions. A weak acid will not convert fully into ions. You'll have a concentration of 0.2 of the acid and then maybe 0.05 of the hydronium ions. Remember, I'm adding water to an acid. This is a non-metal combined to a non-metal, and therefore I'm calling it ionization. if I use a strong base, let's use sodium hydroxide, then I don't add water basically. This is called dissociation. So water is written on top of that arrow. And this converts into sodium ions and hydroxide ions in solution. This is called dissociation. Dissolve basically. So these two will, this is dissociation, the strong base, and the strong acids ionization. But the principle is the same. If my concentration is 0.3 moles per cubic decimeter, the hydroxide ions will also be 0.3 moles per cubic decimeter, and so will the sodium ions have the same concentration. So this fully dissociates and acids fully ionizes. That is important because pH is calculated the following way. I'm going to give you a couple of equations that you can use to calculate pH. And I'll give you a table of strong acids, and strong bases are easy to remember, so we don't need a table for that. Let me just get this black screen gone. There's your equations. Let's just do this. There's your equations to calculate pH. I'll explain it now. So we are basically going to use this one, which is the same as that one. So pH equals minus the logarithm of the concentration of the hydrogen ions, or pH equals minus the log of the concentration of the hydronium ions. They're exactly the same. If you look at it, basically hydronium is just water added to the hydrogen ion. And we are going to use this equation here. That's called the ionization constant for water. And that is 10 to the power of minus 14. Okay, you won't understand this now, but those are the three, basically any of those, we're not going to use the middle one at all. You don't need the green one. Right, and then so you can make a proper screenshot, just want to give you a table of strong acids. We can't see there. Let me just do a better picture if I can. And then I'll show you what a strong base is. And there's a couple of them that you must learn off by heart. Otherwise, you're not going to know what to do. This is all just introductory. I'll show you how to do the calculations now. It's not difficult. Right, there's your table of strong acids. And it's only those that are large or very large that are considered to be strong acids. This Ka value basically gives you the concentration of the ions in when they ionize. So it's only these: hydrogen iodide, hydrogen bromide, hydrogen chloride, HNO3, what's that called in English? Nitric acid, eh? And then H2SO4, sulfuric acid. So you're going to use HCl with HNO3 and H2SO4 most. Those are the three acids you're going to use. They are strong acids, and all three of them will fully ionize. Let's understand that in a minute. Then my strong bases are not difficult. A strong base is generally a group 1 or 2 metal that combines with hydroxide. So sodium hydroxide, potassium hydroxide, magnesium hydroxide, all of those are strong bases. Okay, let's see how the calculations are done. It's not difficult. You need a calculator for this. Right, number one. I want to know, what is the pH? What is the pH of, let's say, of a hydrochloric acid, with a concentration equaling 0.06 moles per decimeter cubed. So let's see what happens here. I've got hydrochloric acid, and I'm going to add water to it. So it ionizes, AQ and liquid. And then the hydrochloric acid is going to donate a proton to the water. So it becomes hydronium ions in solution and also chlorine ions in solution. So HCl is a strong acid. So the concentration here, 0,06, determines the concentration of the hydronium. So the concentration of the ions will be exactly the same as the concentration of the acid. Why? Because it fully ionizes into ions. So now I'm going to use my equation. pH equals minus log of the concentration of the hydronium ions. And I'm just going to type in minus log 0,06 in the calculator. And let's do that. What's that? Log is a button on your calculator. Do you get 1,22?
Yes.
Denise?
Yes.
Right. Would you say that's in strong acid? Yes. Remember this table. I don't know if you've worked with this table before, but we start from 0 to 14. Anything below 7 is considered to be acidic. And everything above 7 is considered to be a base. Okay. So 1,22 is regarded as like a strong acid. 7 is neutral. Do you know that? I didn't.
Yes.
I thought it was like everyone knows that. If you've got a swimming pool or if you've worked with a swimming pool or something, you'll know that. Okay, cool. Let's just do another example. I'm gonna do everything you can get on this, and then I'm gonna show you why we're doing it. Okay, we have nitric acid, HNO3. Let me try and write a bit neater than that. HNO3. We have a sample of nitric acid. No? And that nitric acid has got a pH value of 1,14. So there's our sample of nitric acid. Bing. And it's got a pH of 1,14. Right. And the solution has a volume of 300 milliliters. So there's my nitric acid solution. We dissolved some nitric acid into water, and the total volume is 300 milliliters. Okay. What is the mass? What is the mass of nitric acid we added to the water? I'm going to give you an equation. HNO3 solids, so it's a powder. We added that to water. That ionizes. The nitric acid donates a proton to the water. It becomes hydronium ions. They might give you this. That's a Q. Plus NO3 minus. So I want to know, okay, this was 300 milliliters of water. This was solid. So I want to know what the mass was. How many grams of nitric acid did we add to the water? Okay, we can work in reverse now. Why? Because the concentration of my hydronium ions here is exactly the same as the concentration of the nitric acid. Why? Because nitric acid is a strong acid and it will fully ionize. You are really not going to work with weak acids. You can, but it's never been asked. Once we've done Le Chatelier's principle and all the calculations there, then we can revert back. I can show you how you should work or can work with with a weak acid or a weak base, but we can't do that yet. So I'm going to go and say pH equals minus the logarithm of the concentration of the hydronium ions. So the pH value was 1,14, 1,14, and that equals negative log hydronium concentrate. Okay. Now, I don't know if you've done log laws, but basically a log with no base here is invisible 10. And you can get that log away by writing 10 to the power of 1,14. But if you haven't done log laws, it's fine. You don't have to. You've got a button on your calculator that you can inverse log. So I'm first going to just multiply with a -1 right through. So I can actually get that log positive on that side. So I multiply -1 right through, 1,14 minus 1,14 equals log invisible base 10 hydronium ions. And now I'm going to type this in my calculator, shift log. So if I press shift log, if I do shift log in my calculator, it will automatically give me 10 to the power of blank. So therefore, 10 to the power of -1,14. So I type in shift log, it gives me 10 to the power of, and then I write that in. So that I got rid of, it's like shift tan or shift cos. So if I had cos alpha is 0,21. I want to get rid of the cos, I type in shift cos 0,21. Now I just type in shift log -1,14. So it's 10 to the power of -1,14. And that will give me, I'll just write this, equals concentration hydronium. This step you don't have to show. I'm just showing you what you have in the calculator. Therefore, the concentration hydronium is what? 0,072. I'm going to use 5 decimals. 44. That's more than 5. Yeah, that's 5 decimals. Mole per decimeter cubed. Just quickly look at this calculation. It's very new now, but it's not difficult. You use this this pH equation. You wrote in everything you got. And then you just made that minus. You got rid of that minus by multiplying with the negative right through. And then you just did anti-log. It's called anti-log or shift log. So you got rid of the log by typing in shift log. It immediately gives you 10 to the power. And then you're writing that -1,14. And then you get the concentration of the hydronium ions. But because it's a strong acid, that will give you also the concentration of the acid. HNO3, nitric acid, also therefore have a concentration of 0,07244 mole per decimeter cubed. Why? It's a strong acid, and it's the full concentration, or all of the nitric acid was converted into ions. So the concentration of the ions are exactly the same as the nitric acid. And then what? Then I can work out the mole. The mole is the concentration times the volume. And that is that answer I just got times the volume of the water. Remember, I must work in cubic decimeters. So I'm not allowed to work in milliliters. Let's just quickly do that sum and just make sure that you can do that to know what I'm actually doing, why I'm dividing with 1,000. So the mole are 0,02173 mole. Okay, let's just go through that. Why did I do that? Why did I divide with 1,000? Why did I convert 300 milliliters to liter? Because cubic decimeter and liter is exactly the same unit. They're the same. And cubic centimeter is exactly the same as milliliter. So whatever you do to get from milliliters to liters, you must also do from cubic centimeters to decimeter. So you must work in those standard units. You can't work in milliliter or cubic centimeter. So now I have the amount of mole of nitric acid. And I think you can all calculate the mass now. The mole is the mass over the molar mass. So the mass is 0,02173. Molar mass of nitric acid, hydrogen, plus nitrogen, plus 3 oxygens. So I'll keep that value in my calculator. And I'm just going to calculate or add, multiply that with 15 plus 3 times 16, because 1 plus 4 is 15. And then I get 1,37 grams. So this is like 5 marks. Are you happy or not yet? Not really. Tatu? Ach, Tatu, Kutsu?
Yeah, I feel like do another one.
Yeah, a couple more. Eh?
Yeah.
Okay, right. Let's do exactly the same one. We just make it slightly harder. I'm throwing you into the deep end now. I know that. Because there's not these ionization formulas you have to know as well. You have to be able to write the formula for it. Okay, let's go to sulfuric acid. We do exactly the same. H2SO4, that's sulfuric acid. And we have a sample of sulfuric acid, and it's got a pH value of 2,1. Remember, pH doesn't have a unit, it's just a value. So the first question is, write a formula of the ionization of H2SO4. They might give this to you because this is a difficult one. Who of you know this? If I take sulfuric acid and I add it to water, what happens? It ionizes not once, but twice. Why? This is called a diprotic acid. So it has got two hydrogens that it can donate. So donating the first hydrogen gives me hydronium ions and HSO4 minus in solution. Then it will ionize again. That HSO4 minus will react with water again, and it will donate another proton. And it will give me SO4 2 minus ions in solution. So sometimes they just write it like this. They add these two equations, and you get H2SO4 plus 2 moles of water gives me 2 moles of hydronium plus SO4 2 minus. Basically what happened here, they canceled this on the left and that on the right, and they added everything. Can you see that?
Yeah.
This is a very, very, very important ionization formula to be able to write. Okay, the implication is as follow. I have 2 moles of hydronium for each mole of sulfuric acid. Very important. So when I do this calculation now, and I start with my pH, I go pH equals minus log of the concentration of the hydronium ions. Good. Okay, so 2,1 equals minus log concentration hydronium. Minus 2,1 equals log. You don't have to show this step. I'm just showing you what we're doing. Now you do anti-log, shift log. 10 to the power of minus 2,1 equals the concentration of the hydronium ions. But 2 moles of hydronium ions are delivered from 1 mole of sulfuric acid. So the concentration of the sulfuric acid, square brackets, is concentration, is what? Is half of that. Is 10 to the power of minus 2,1 divided by 2. Okay, so 10 to the power of minus 2.1 equals, you could have written, here you could have written 7,93 times 10 to the power minus 3, but I've just kept that. And I'm just going to divide that with 2. Whoa, no, not minus with 2. 10 to the power of minus 2.1 equals divided by 2. Then the concentration of the acid is 3,97 times 10 to the power of minus 3 mole per cubic decimeter. Once you've got the concentration, then you can work out everything. I didn't give you the volume, so you can't work out the mole. So we're not going to ask you the grams this time. I just want to show you how to work back from pH to concentration. Right. Now, we need to learn another equation. Gonna try and make it easy. We have, let's say, potassium hydroxide, and that dissociates in water to give us potassium ions in solution plus hydroxide ions in solution. Right, so let's say I have, I put in 3 grams of potassium hydroxide into 120 milliliters of water. So the first question is, what is the concentration of the potassium hydroxide? Then I'm going to go, concentration is mole divided by volume. I need the volume. Sorry, I don't need the amount of moles. The mole is the mass over the molar mass. Can you guys still hear me? You are just like dead silent.
Yeah, we can hear you.
Denise?
Yes, I can hear you.
The mole is 3 gram over potassium is 39. Do you have a periodic table there, good sir? Plus hydroxide, which is 16 plus 1. Let's work out the amount of mole there. Zero comma 0.05357 whatever mole. Okay, I'm not going to clear the calculator because I need that value to pop in there. So my concentration of potassium hydroxide is 0.05357, the answer basically, over the volume, which is 120 divided by 1,000. Are you with me? I have to work in liter or cubic decimeters. So I'm just going to divide that answer with 120 divided by 1,000, or 0.12. And then the concentration is 0.4464. So the concentration is 0.45 mole per cubic decimeter. Okay, it was a question, so I'm giving a final answer rounded off to 2 decimals. Okay, now pH. Let's do it here. 3.2. What is the pH of the solution? Right, let's do that. pH equals minus log of the concentration of the hydronium ions or hydrogen ions. So in other words, you can write hydronium there, or you can just do hydrogen ions. Same thing. Problem is, I don't have any hydrogen ions in my equation. So now I can first go here to that kV value of water. So the concentration of the hydrogen ions times the concentration of the hydronium ions equals 10 to the power of minus 14. That's like a constant. Great. So I can calculate that. The concentration of the hydrogen ions, well, I can get the concentration of the hydronium ions. How can I get that? Well, it's a strong base. Look, I've got a group 1 metal with hydroxide. So whatever concentration I've got here will be fully dissociated into that concentration. So the concentration of the KOH, which is this value here, is exactly the same as the concentration of the OH ions. So I can just put the 0.45 in there, and that will give me the concentration of the hydrogen ions. So now I can go 10 to the power of minus 14 divided by 0.45. And then I get 2,222 times 10 to the power of minus 14. And then I pop it in there. Therefore, pH equals minus log of that answer. So you can't do this in exam. You have to write the values in, but I guess you know that. And 13,65, the pH is 13,65, and that's a very strong base. It is a strong base. Look at that. Right, so what is the important thing to learn here? If you have a strong base or a strong acid, the concentration of the strong base or strong acid will be fully converted into the concentration of the ions. So I can get, if I can get the concentration of the ions, I can get this concentration of the base. If I can get the concentration of the base or the acid, I can get the concentration of the ions. If I have to work out a base, I have to include this equation here. Why? It's going to help me to get the concentration of the hydrogen ions, and that I need in my log equation. So let's revert this one in the next example. I have what? I have lithium hydroxide. And that dissociates in the water to give us lithium ions and hydroxide ions. Right. Now, we use 200 milliliters of water. So our solution has a volume of 200 milliliters of water. And the pH equaled 12,92. I want to know what mass of lithium hydroxide did we add to the water? So what's the mass of the lithium hydroxide? Okay, cool. Let's go through sequence. I need to find the concentration of the hydroxide ions. If I have the concentration of the hydroxide ions, I have the concentration of the lithium hydroxide. If I have the lithium hydroxide concentration, I can work with that N equals CV formula to get the amount of mole. If I get the amount of mole, I can get the mass. So this is our sequence. Get that one, and that one will get you that one, and this will give you the mole. Once you've got the mole, then you can do anything. All right, but now I have a problem, small problem. pH equals minus log of the hydrogen ions, not the hydroxide ions. Okay, so if I work with pH, I'm not going to get the hydroxide ions, I'm going to get the hydrogen ions. But that's not a problem, because I have this formula that can help me to get the hydroxide ions. Good. 12,92 equals minus log hydrogen ion concentration. So shift log minus 12,92 on the calculator. Shift log minus 12.92 equal 1,2022 6 whatever times 10 to the power of minus 13 equals hydrogen ion concentration. And that value I can pop in there. Right, cool. Therefore, my hydroxide ion concentration equals 10 to the power of minus 14 divided with that answer. 1,2002 times 10 to the power of minus 13. So I'm just going to go fraction 10 to the power of minus 14 on top and the answer at the bottom. So my hydroxide ion concentration is 0,083176 mole per cubic decimeter. I'm using 5 decimals at least. Why? Because it's not the question. And I'm not allowed to round off now, unless you keep that value in your calculator the whole time and reuse it. So therefore, the lithium hydroxide has the same concentration. Why? It is a strong base. It dissociated completely into ions. So the concentration of the ions is exactly the same as the concentration of the lithium hydroxide. Cool. So now I can use this formula. Concentration is mole divided by volume. Or maybe it is mole is concentration times volume on your sheet. It's the same thing. So I can get the mole by taking the concentration, that value there, and times it with my 200 milliliters, which I need to divide with 1,000. So I've got that answer in my calculator. I'm just going to times it with 200 divided by 1,000 in brackets. And then the amount of mole is 0.016635. So now I've got the mole of lithium hydroxide. And then I can use the formula. Mole is mass over molar mass to get the mass. The mass is the amount of moles, 0.0166 times the molar mass. Lithium is 9, I think. Is it 7 or 9? 7. Come, you must have a periodic table in front of you to learn where the stuff is. And I've got a hydroxide, which consists of oxygen and hydrogen. So I'm just going to multiply that with what? 24. And I get 0.4 grams. That's the mass. It is nice. It's a big sum. It's not difficult. It's just a lot of new things that you have to look at. Okay, so let's just move to a normal titration. I want to show you why this is necessary. You are going to get sums like this. So the next step we're going to go is not important for now. I just want to show you how it connects to the stuff you've done in grade 11. So now I've got here a beaker. And let's say I've got a base in there. Let's make it really simple. I have sodium hydroxide. And the volume is 200 milliliters. Excellent. The concentration, I don't know. Then I'm going to take a burette, a little tap there, and I'm going to put in an acid. Let's keep it really simple. I'm going to put in hydrochloric acid. And you know what? I'm going to put in a volume of 120 milliliters. And I've got a pH value there. I don't have concentration. pH is 1, what? 1. Right. So I want to know, if I titrate this HCl with sodium hydroxide to give me sodium chloride and water. I'm not going to add the subscripts. I want to know, if I do a titration here, a titration means I'm adding just enough for the two to neutralize one another. Then this color will change. It actually will become like a greenish, pinkish. I want to know, what is the concentration of the sodium hydroxide? Okay, that means I need to find out the mole of the HCl. All right, so I need to know this equation. I need to add this for myself. They're not going to give you this. You need to realize that for hydrochloric acid to become an aqueous solution, it first needs to actually react with water. This is a liquid, the acid. So I'm not throwing in like a stone or like a powder or something. I'm throwing in a liquid. And before it became a liquid, or it had to react with water. This is important. So the pH will help me find that hydronium ion concentration. And then I know what the concentration of the hydrochloric acid is. If I have the concentration of the hydrochloric acid and its volume, I can actually work out the amount of mole. So let's go. pH equals minus log of the hydronium concentrate. 1,1 equals minus log concentration hydronium. Shift log minus 1,1. Shift log minus 1.1. And that will give me the concentration of the hydronium ions as 0,07943. mole per cubic des. Boom. Okay. Therefore, the concentration of my HCl is also 0,07943. So I can get the mole. The mole is the concentration times the volume. So it's 0,07943 times 120 mole is 0,12, or 120 divided by 1,000. So I'm just going to multiply that with 0,12. And then I get the amount of mole, 9,5319 times 10 to the power of minus 3 mole. Bang. Okay. Excellent. Why? Because my hydrochloric acid and my sodium hydroxide is in a mole ratio of 1:1. So this you did last year. So I'm not really sure how well you know this work, but you can immediately know that the amount of mole of sodium hydroxide will also be 9,5319 times 10 to the power of minus 3, because the ratio is 1:1. 1 mole of hydrochloric acid will neutralize 1 mole of sodium hydroxide. And then I can work out the concentration. The concentration is the mole divided by the volume. And that's that answer divided by the volume, which is 200 divided by 1,000. Right, answer divided in brackets 0.2. And then the concentration is 0,05 mole per cubic des. So I'm just showing where we are going. We are going to learn how to work with pH, determine pH values, work from pH to concentration, because we need to use that in all the acid-base reactions we're going to do. Titrations and other limiting reagents. Remember that? Can you remember limiting reagent? Percentage purity. Can you remember that?
Yes.
Good, so?
Yes.
Denise?
Yes.
Okay. Right. So one difficult sum that you have to do on your own. Right. I have calcium hydroxide. Look at that. And I have 8 grams, which I dissolve in 250 milliliters of water. Good. I'm going to help you with number 1. No, I'm not going to help you. I'm going to get easier. I want to know, what is the concentration of the solution? So nothing, no pH now, just what's the concentration of the solution? Easy peasy. Let's just do that. I'm going to give you a formula. Mole equals concentration times volume. Go. And if you don't have a periodic table, calcium's molar mass is 40 grams per mole. Oxygen is 16, and hydrogen is 1. My answer's got a lot of values less than 5 in. And it's like repeating one another. There's a pattern. Do you have an answer?
Yes, but I'm not sure.
I get 0,432432. Okay, let's see. Right, the concentration of the solution. Let's get the formula going. Concentration is mole divided by volume. I've got the volume. The volume is 250 divided by 1,000. I just need to get the mole. The mole is the mass over the molar mass. It is 8 grams over 40, which is calcium, plus 2 of the OHs. Right, so that gives me what? 8 divided by 40. Always do it in a fraction form like that. It helps you.
I have 0,1081 substitute.
Yeah, mole. It doesn't matter. I'm just going to press answer divided by. So I'm just going to do fraction, answer on top, and 250 divided by 1,000. Then I get 0,432, whatever, 432. Okay, this is a question, so I'm going to leave it at 2 decimals. Is that correct?
Yeah.
Bang.
Yeah.
Okay, now, what's the next question? Do you guess? You have to guess. What is the pH? Now, this is a bugger, this one. Because look at this. Calcium hydroxide is going to dissociate in water. It's a base, so it dissociates. Remember, if there's a metal combined with a non-metal, it's not reacting with water, it's just dissolving. So you can't write plus water. So there's calcium 2 plus ions in solution, and look at this. 2 OH minus ions. For if there's 2 OH. So for every 1 mole of calcium hydroxide, I get 2 mole of hydroxide ions. So I've got 0,43 mole per decimeter cubed. So if I convert it that way, I can say that the concentration of the hydronium ions equals what? 0,43 times 2, because there's 2 moles for each 1 mole of calcium hydroxide. It's not a nice sum. Times 2. Okay, I'm going to just write 0,43 times 2. So that's 0,86 mole per decimeter cubed. Right, this is a massive sum. Right, let's go. So OH concentrate times hydrogen ion concentrate is 10 to the power of minus 14. I can get the hydrogen concentrate by taking 10 to the power of minus 14 and divided by 0,86. So fraction 10 to the power of minus 14 divided by answer. Oh, I'm not sure if the answer was that answer, so I'm just going to retype it in. 0.86. Yes. So that is 1,1627 times 10 to the power of minus 14 mole per decimeter cubed. So pH equals minus log the concentration of the hydrogen ions. And therefore it's minus log that answer. So I'm going to type in minus log answer, close bracket, 13,93. That's very high actually. Calcium hydroxide is not, it's not such a strong base. But anyway, I've thumb sucked these values, so they're right. It's interesting to get a large answer like that. So it's a huge sum. This video I'm going to put on YouTube as well. You need to actually do this, work through it. And also for next week, also look at Le Chatelier's principle. I don't know how you're going to get time to do everything. I really don't. Otherwise, you're just going to get back to me and say, sir, I'm not going to get time to go through chemical equilibrium for next week because blah, blah, blah. And then I'll work out something for you just to get you going with it. Just to get you the marks. Basically what I do, I just sift through the stuff and just take out all the stuff that you need to understand. All the stuff that you need to learn, you still have to go and do on your own. Okay.
Right.
Right. Look, you must just take it as it is. It's not possible for me to run through the whole chapter with you. I mean, I haven't explained acid and base pairs to you. I haven't explained Arrhenius model or Lewis model or whatever. Laurie Brownstedt's acid and base model. That's all theory that he even did last year. You remember that?
Mm.
Okay. Good. I want you to have more questions. I want to work on your questions, not on my own. All right.
Right.
Bernice,
Yes.
I get worried if there's no questions. It means that you either know everything, then you don't need me, or you haven't done anything. Good. I'll see you next week or Friday. I'm not sure.
Thank you.
Okay. Keep well. Bye.
Bye.
Bye, Bernice.
Bye.